page 10, adding and subtracting polynomials. This is still kind of a review of what you did in Algebra 1, but it is our Unit 1 in Geometry. So first we need to talk about a couple of vocab words that are very important that you're going to hear. The first one is polynomial. Polynomial is an expression made from one or more terms that involve constants, variables, and exponents. Poly means many, so it is an expression of many terms. The term word means parts of an expression. Some examples. X cubed is a term. I'm going to draw a slash to separate. It doesn't mean divide. I'm saying, hey, here's another example. Negative 5x squared is a term. Even simple numbers by themselves, like 4, is a term. Okay? Terms are separated by plus and minus signs. Terms are separated by plus and minus signs. You will also find that terms are always nice, pretty numbers. Polynomials do not have fractions, which is why I love polynomials. They don't have fancy square root stuff. They don't have any of that. It's always integers. Integers are the nice, pretty numbers. If I gave you a number line that most people label it with, those are integers. So like -3, 0, 1, 5, 10. Nice, pretty numbers. Coefficient is also a vocab word that you need to know. It is the number in front of a variable. Variable means a letter. So for example, if this is our example that we're looking at right here, we broke it down to show that x cubed, negative 5x squared, and 4 are the 3 terms that are in this polynomial. What is the coefficient of the x cubed term? You would come right here in front of it and you would look, and in this case it is the number 1. What is the coefficient of the x squared term?
-5.
-5. Constant is a term that contains only numbers, no letters, no variables. So for instance, this example, what is the constant? 4. The constant is 4. When we're dealing with polynomials, it is common practice to put it in what's called standard form. Standard form is not by the numbers in front of the letters, it's by the exponents. Okay, so it has to be written what's called alphabetical order if we have more than one letter, which we probably won't have. With the highest exponent first. Highest exponent first. And then here is another vocab word embedded in this. The highest exponent is called the degree, and that is very important. If you have a highlighter, you may want to highlight that word. You will hear that word a lot. You need to know what I mean by degree. Here's a way to remember it. Stupid and corny, but maybe it'll work. If I say to you, how hot is it outside? You would tell me the highest temperature degree, correct? You would say, hey, it's 92 degrees outside. Okay, so I want you to equate, how hot is it outside to highest temperature degree. So if I say, what is the degree of a polynomial, I'm asking you to tell me the highest exponent. So looking at this example right here, what is the degree? Well, what's the highest exponent? Exponent. 3. That's the little superscript part, right? So you have 3, 2, and then none. So the highest exponent would be 3. So you would say that the degree of that polynomial is 3. Come to this example right here. Write this in standard form. It's a cup game. Y'all know the cup game where you have 3 cups and a little ball and you put it under one of them and then you slide the cups, right?
Yeah.
And you say, which one's it under? It's a cup game. We're going to shuffle all of these terms to meet the standard form requirement. Before you go and shuffle, it would help if you draw a slash in front of every sign. So like right here, 3x squared. Oh, there's a plus. Draw a slash. Because that plus goes with that 2x. Then you have positive 2x slash. Then you have minus 1 slash. Then you have positive 5x to the 4th. So how many terms do I have here, y'all? You have 4. 1, 2, 3, 4. So I want you now to imagine that's 4 cups and you're shuffling them with their signs and you're putting it in standard form. So to do that, you find the term that has the highest exponent. It has to go first. And that would be which term? And it's positive. Do I write the plus sign? No. When it's in the front, if it's positive, don't write the plus sign. All right, so that term's done. Now you count down from the exponent. So that's a 4. Is there a 3 exponent? No. So you don't worry about it. But then there's a 3x squared. Do I just write 3x squared?
Plus.
You need to put a plus sign there because it is positive. Then next would be the understood 1 right there. So plus 2x. And then that is a constant, so you put minus 1. Okay, the next part. When you're talking about polynomials, you're discussing it based on 2 things. One is the degree, so the highest exponent, and the other is how many terms it had total. Okay? There are vocab words associated with this. You need to know all of these. You need to know them. Now, they're self-explanatory. They really are. So when we go over this, I'm going to show you. It's not like it's a new vocab word that does not have a thing related to what it actually is. Like it's self-explanatory. Let me show you what I mean. If it has a degree of 0, it's called a constant. For example, I'm going to put examples over here. For example, if I said that this was your polynomial, that's just a number. What did we say was a term that's just a number? A constant. So if the highest exponent is 0, which means you can't see it, then it's a constant. You might say, well, where is the exponent? There's an understood x to the 0 power there that you don't see. Because x, anything to the 0 power is 1. So you don't know. This you already know. Highest degree is 1. Linear. Y'all graphed lines last year in algebra. You already know this. So for instance, say you had a polynomial of 2x. That's linear. Because it's x to the 1 power. Highest degree is 2. Say we had 4x squared. That's quadratic. Highest degree is 3. Is called a cubic. Let's say we had 5x cubed. Highest degree is 4. Honestly, you don't say quartic that much. You just say degree 4, degree 5, degree 6. These right here, these first 4, are the most important ones. This, not so much. We don't use it as often. We usually just say it was degree and then whatever the number is. But an example here, like 6x to the 4th power. So you name it by what the degree is, then you name it by how many terms it has. All of those are monomials. Okay? Monomial means it's just one term. What's monomial? Like mono. Mono means one. Binomial, 2. Trinomial, 3. And then anything higher, you just say polynomial. In fact, I sometimes call a trinomial a polynomial already. Now, binomial and monomial, I will say. Sometimes I call a trinomial as just a polynomial. So let's look at this. Here's an example. Negative 8x plus 4. Is it a constant?
Linear.
There you go. It is to the first power, so it's a linear, and it only has how many terms?
2.
2. So it's a binomial. Now the second example is a trick because it is not in standard form. Right? So you have to look at it carefully. It is a cubic.
Trinomial.
And it's a trinomial, or you could say polynomial. Okay, so now we're getting to adding and subtracting. It is what you already know, like in the warm-up, you added like terms in the warm-up before you started moving things. So that's the same concept. The rule when you're adding and subtracting, you combine like terms. What do we mean by like terms? They have to have the same variable, and I'm going to put in parentheses an S, because you could technically have more than one variable, and if you do, they have to match. It also has to have the same exponent. Think of the variables and the exponents as like a last name. You can't combine it unless the last name matches. So look at number 1. We're adding this mess to this mess, right? Multiple ways to do this. If it were me, just starting to work with stuff like this, I would get in the habit of writing underneath it however many like whatever the exponent is, you're going to write that number of lines. So watch. This is y to the what? This is y squared. I'm going to put 2 y's. This is y to the what?
First.
So there's 1. This is a constant. This is y cubed. This is y to the 1. This is a constant. Because if you do that, now you can visualize what actually will combine. And you also can see what needs to be in the front, right? This has y cubed. That should be in the front in order for it to be, I've already scrolled up, in order for it to be in standard form. So this 2y cubed right here is going to go first. Then what should go next? Plus 5y squared. And then now we have to combine positive 7y minus 6y. So if you have 7 y's and you take 6 away, you have 1 left. So it would be plus y. Y'all see how I got that? And then the constants. Negative 2 plus 4 is positive 2. Okay, number 2 is the exact same thing. The difference is they didn't give it to you as, hey, this plus this. They used the phrase find the sum. So you just have to know that sum means to do what? Add. So another way to do it, if you have it written like this, is you can stack them. Y'all do what you want to do. You can stack them. 3a squared will combine with negative 14a squared. 5a will combine combine with negative 5a. And then there was nothing else. So then you could draw your little line and add straight down, right? So that's another way to do it. So negative 14a squared plus 3a squared.
Negative 11.
And then what happens here? They cancel, so don't write it. And then bring that down. Okay, what about subtracting? If you will remember to distribute the negative first, once you distribute the negative, you're no longer subtracting, now you're just adding. So it is still adding like terms. You have to distribute the negative first or you'll get it wrong. So right here, there is an understood negative 1, and it is going to change the sign of everything after it in the parentheses. So this, and this will no longer have that sign that you see. They will change. So one way to do it is to just bring this down and then start changing. So that's positive 7 is going to become negative. That becomes negative. And that becomes positive. And then now combine like terms. So I have 6x5 minus 7x5 negative x to the 5th. I have no 4 degree. I have negative 1x cubed minus 2x cubed.
Negative 3a.
I have no squared. Then I have x plus 3. And that's it. All right, you try 2 and then let's check it. Good? Everybody should be trying that second one. All right, what'd y'all get?
Negative 2w3 plus 8w minus 2.
Well, I asked thinking I would know the answer. I don't know. Negative 2w plus what?
Oh, my bad.
Negative 2w cubed
Okay.
plus
So
8w
first, oh, okay.
minus 2.
Minus.
Minus 2.
Minus 2.
Yeah.
Yeah. Okay, so you should have distributed this, right? And then, so this would come down. And then negative 8 plus 6, 4 plus 4, and then copy, right? Okay. Okay, let me ask what you want to do. Do you want me to show you multiplying with 4 examples, well, 5 if you count that one, and then all day tomorrow we'll be practicing, or do you want me to let you start practicing that now, which will be just a few problems, then tomorrow I would teach this, and then we would practice the remaining problems.
I'll say option 2.
Okay. All right, not a problem. Okay, so let me stop the video. Let me show you an example of something that comes up. It's on Delta Math, which I was considering assigning, which I thought you were going to be like, just take your shoe off and throw it out.
Yeah.
Let me show you. I want you to write this in. You don't have room. Go to the back and just put it on the back of your notes. I want you to write. Watch out. Vehicle on shoulder. What'd you say?
On the back.
Yeah, on the back. Watch. I want you to write "watch out," and then I want you to copy. Well, you don't have to put the quotation marks. I don't know why I did that.
Is that BX?
B. Oh no, that's a 6. Sorry,
Oh,
my 6 sometimes looks a little like a B. Sorry.
it's alright.
This is not going to happen today, but if we do a Delta Math assignment, it could happen, or it could end up on our test, which is next week, by the way. Subtract 4x plus 1 from 6x minus 7. So it sounds like a basic subtraction problem, right? There you go. The problem is this. This is tricky. Let's write that. This is tricky. It's saying take, relate it to smaller numbers. What if it said take 3 from 8? Well, no, if it said take 3 from 8, it would be 8 minus 3. So if you have something written, hey, take blah from whatever, then it's the reverse order, and that's what you need to remember. So this would be 6x minus 7 minus, and you need to put parentheses around whatever you're subtracting, because you have to distribute that negative. So you have to remember parentheses. They don't matter in the first ones. They matter in whatever comes after the subtraction sign, because, here we go. So this comes down, this becomes minus, and then now we've got 2x minus 11. Me? It's phonetic.
Why'd you put 1 up there?
Wait. This should not
That
be.
should be a 7.
Wait, I thought it was 2x.
Hold on. That's not supposed to be a 4.
Thank God. Yeah, that's supposed to be 1 that's 2x minus 8. Yes! I was like, hold up.
I think when I looked at this, I was thinking the parentheses was a 4 for some reason.
Oh.
So I'll show you this example to say, watch out, it can happen. It will not happen today, but it could happen.